Yeah, welcome to Excel class hub. I still remain Mr. Adekunle Samuel, aka Crusher. Now, I want us to treat one topic in mathematics, especially for you, your JAMB student. Remember, JAMB says don't use what? Calculator. And there's some topics in math you need to understand before you go further. Without you understanding all those topics, you have problems. Let me give you, for example, like topic like calculus. There are some topics you need to attain before you get to what? Calculus, before you start talking about calculus. What are the topics you need to know? If you can understand those foundation of those topics, if you understand those topics very well, your foundation in mathematics will be what? Will be solid. Example of such topics are when you go back to something like indices and logarithm, you take your sword. Are you with me? You take your what? Your trigonometry what? Your ratio. Because remember, sword will help you out how to solve question, leaving your answer in what? In solved form. That's why you see some of your options in your exam. You see the options there. They have to leave their answer in what? In solved form. But in a nutshell, I'm not here to take you what? Solve. But as time goes on, I believe we're still going to talk about what? Solve. But what I want to talk about this morning, we'll be talking about a topic called trigonometry what? Ratio. But that topic will now take us a little bit advanced to what they call identities and what they call the compound angles. Because without compound angles, you should be able to solve, leaving your answer in solved form. Just like if JAMB should ask you now that find the value of sine 15. How do you want to find the value of sine 15 degree without using calculator? So definitely your answer here has to be in what? In solved form. If you're with me, if you're home, if you can press this thing in your calculator, root 6 minus root 2 divided by 4. I believe root 6 minus root 2 divided by 4 must give you the same value of what? Sine what? 15. Or root 6 plus root 2 divided by what? 4. Still give you the same thing, which is the same thing as cos 15. Out of this sine 15, cos 15 will give you is either this or this, leaving your answer in solved form. You can see that from the word cosine, it's talking about what? Trigonometry what? Ratio. When you solve this question, the answer there is left in what? In solved form. So that is why I said solved is very, very, very important. Very important for all students to understand as what? Your foundation in what? In mathematics. But now we're going to take a look at what they call the trigonometry ratio. Trig. Ratio. From your trigonometry ratio, remember, we have some shapes. Remember, I believe you remember this shape. What do I call this shape? This shape is called what? A triangle. We call it what? A triangle. Let me break it down. If you pick a knife, when you pick a knife, if I should cut this triangle into two, remember it will split into two. When you have a triangle, when you split it into two, it will have something like this. So half of a triangle is called the right angle triangle. Half of a triangle is called what? The right angle what? Triangle. So what they want to make use of? They want to make use of what they call the what? The right angle triangle. So if I'm to pick right angle triangle, I have a diagram like this. For my right angle triangle, I'm having something like this. My right angle triangle. This is a theta. When you have something like this as your right angle what? Triangle student, if you look at this right angle triangle, this right angle triangle. From this diagram student, how many edges am I having there? 1, 2, 3. I have 3 edges there. I can decide that this place to be what? A. This place to be what? B. And I can decide that this place to be what? C. For my right angle what? Triangle. Now look at it now, student. If you want to cross an express, remember you look right and you look what? Left. Assumption. Let's assume that this place here now is an express. If this place here is an express, if you look your left hand side, what are you seeing there? A. If you look right hand side, which alphabet are you seeing there? C. That means I'm assuming that this place is an express. If you look left, you see what? A. If you look right, what will you see there? C. Can you see this B? No. So definitely this place will be small letter what? B. When this place is B and C, definitely you're supposed to be small letter what? A, and you're supposed to be small letter C. And if you look at the three sides there, which one is the longest side there? You can see that the longest side there is what? A to what? C. Length of A to C is the longest what? Side. So the longest side, we call it what? The hypotenuse. It is called the what? The hypotenuse. Why this side there is called the opposite. And this side there is called the adjacent. So the longest side is called the hypotenuse. Why here is called the what? The opposite. And this angle here is called the what? The adjacent. So let's move. First and foremost, we start with what they call the Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. Pythagoras theorem. From your Pythagoras theorem there, the formula says the square of the longest side. Pythagoras theorem says the square of the what? Longest side is equal to the sum of the square of other both sides. Now, what am I trying to say now? The square of the longest side. So what's my longest side there? Hypotenuse, which is HYP. I can put this sign, which is the square of the longest side, is equal to the sum. The meaning of sum is what? Addition. When you have something together. Sum of the square of other what? Both sides, which is opposite square plus what? Adjacent square. Adjacent square. If I don't want to use this hypotenuse, the square of the longest side, the length of the longest side is A to what? C. I can still change it to what? AC. Everything what? Square. My opposite can still be what? AB. Everything what? Square. Plus y or adjacent will be what? BC. Everything what? Square. If I still want to use this one, I can still use the longest side is still small letter what? B. I can decide to change it to what? B square. I can change it to what? B square equals to what will be my AB there will be what? C square. Plus y this one will be what? A square. Which is a formula for your what? Your Pythagoras what? Theorem. Student, we now move a little bit what? Advanced. No time to check time. There's something we call the SOHCAHTOA. SOHCAHTOA. We call it what? SOHCAHTOA. How many alphabets am I having there? 1, 2, 3, 4, 5, 6, 7, 8, 9. SOHCAHTOA. So you take it 3, 3. This X here stands for what? Sine theta. It is called what? Sine theta. Sine theta. Sine theta is equal to what? This O here stands for what? Opposite. Over the H there is what? Hypotenuse. That means from this so means sine theta equals to what? Opposite over what? Hypotenuse. But I can still change it back to alphabet. From the diagram here. Opposite over what? Hypotenuse. What is my opposite, student? C. And your hypotenuse is what? B. So it can give me what? C over what? B. If you go to the next one, K. That C there means what? Cos theta. Equals to the A there is what? Adjacent. And your H there is what? Hypotenuse. So which will give me adjacent over hypotenuse there will be what? A. You know, your adjacent is A, B. And your hypotenuse is what? B. So that should be what? A over B. If you go to the last one there, toi. This thing here means what? Tan theta. Tan theta, which means O is what? Opposite. And your A is what? Adjacent. If we change it back to alphabet again, that should be what? C over what? A. So I'm having C over what? A for your what? Your SOHCAHTOA. Aside from SOHCAHTOA, we still have what they call the inverse. They call it what? Inverse. It's called inverse. The first inverse, student, that we have there, we have what they call sec theta. What do I call it? Sec theta. Whenever I see sec theta, gives you 1 over cos theta. Whenever you say anything sec theta, gives you what? 1 over what? Cos theta. Sec theta means what? 1 over what? Cos theta. I repeat, sec theta means 1 over what? Cos theta. Which can still give me something like this. You know, this is your 1. Just understanding. What is my cos? This is your cos. Your cos is what? Adjacent over what? Hypotenuse. What is your cos again? Adjacent over what? Hypotenuse. I can change this cos back to what? adjacent over what? Hypotenuse. So your final answer, if I want to remove one, hypotenuse will go up, adjacent will come down. So this one will not be there. Your final answer will be what? Hypotenuse over what? Adjacent, which is your value for what? Sec theta. So in a nutshell, for sec theta in alphabet, you should know that your answer should be what? B over what? A. Are you with me? So aside from sec, we have what they call cosec theta. Cosec theta means 1 over sine theta. 1 over what? Sine theta, which can still give me 1 over. Student, what is my sine theta there? Your sine theta is still what? Opposite over what? Hypotenuse. That should be what? Opposite over what? Hypotenuse. Yes or no? Student, so definitely, if I want to remove the 1, what will be my final answer there? Hypotenuse over what? Opposite, making 2. So in the nutshell, alphabetically order, that should be what? B over what? C. B will go up, C will come down. While the last one there, we have what they call cot theta. And cot theta here gives you 1 over tan theta. Gives you what? 1 over tan theta. So that should be 1 over, if you go back, what is our tan there today? Opposite over what? Adjacent. Are you with me now? So finally, 1 over opposite of adjacent. So your final answer there will be what? Adjacent over what? Opposite, which is the value for what? Cot theta. If you want to understand this topic, student, you must understand the foundation. If you don't understand the foundation, you have problem. Trigonometry ratio is what is wide. Because if you don't understand the foundation, by the time you get to compound angles, double angles, you find it very difficult. And JAMB says a question lasts for 54 seconds, which is not up to 1 minute. Now, I've given you the value for SOHCAHTOA, and I've given you value for what? Inverse. I've given you what? Pythagoras what? Theorem. Let's put ourselves to test today. Let's see maybe all what we have on the marker board here, they are what? They are correct. Look at this question number 1, student. Question number 1. Number 1 says, show that tan theta equals to sine theta over cos theta. Take a look at this. I've not even written anything like number on the marker board because I want to give you the relationship. Question 1 says, show that tan theta equals to what? Sine theta over cos theta. Well, you know, anything means show that also means prove that. We want to prove that maybe anywhere I see tan theta, I can change it back to what? Sine over cos. Or anywhere I see sine over cos, maybe I can change it back to what? Tan theta. So how will I go about this one, student? Look up. That should be tan theta equals to sine theta over cos theta. How will I prove this now? You know, this is my tan theta, student. This is sine theta now. What is my sine theta in alphabet? Or in this, sine theta is opposite over what? Hypotenuse. So I can change this sine theta back to what? Opposite over what? Hypotenuse. You know, this sign here means divide. That is your divide sign. What is now your cos theta again? Cos theta is what? Adjacent over hypotenuse. Adjacent over what? Hypotenuse. So from here, in a nutshell, tan theta can give me what? Opposite over hypotenuse, which is the upper one, the numerator. And you know, this one is your denominator, Abi. You know, this sign here means divide. I can change it back to something like this, divide. I now bring this one to this side, which is adjacent over what? Hypotenuse. So finally, tan theta will give me opposite over what? Hypotenuse. Abi, student, remember divide will change to what? Times. When you change to times, hypotenuse will go up, and while your adjacent will come down. You know, this hypotenuse cancel this hypotenuse. So what's my final answer for tan theta, the student? Which is opposite over what? Adjacent. I solved this question, tan, sine. What's my final answer for tan? Opposite over what? Adjacent. Now come back to the, what's your tan there? Opposite over what? Adjacent. So you now put what? Proved. So I proved it. What am I trying to say in a nutshell is that anywhere you see tan theta, you can change it back to sine over what? Cos. Or anywhere you see sine over cos, you can change it back to what? Tan. That is number 1 what? Example, which I believe that one is clear. I'm going to prove 3 examples for you before we move to what? Identities. Are you with me now? I will teach you how to solve questions. Whenever you see a particular question, how you can solve it using 2 different formulas. You can use one formula to solve yourself. If you want to assist someone sitting close to you, you can use another formula to assist that person without you using the same word formula. Now, this is the question number what? 1. Let's take a look at another question.